Welcome back to the fourth part of correlation analysis. In this video, we are going to learn about the third method of Karl Pearson's coefficient of correlation. In the first method, we have seen, in case of direct method, we have seen how directly we are computing from x and y, right? In case of arithmetic mean method, in case of arithmetic mean method, we have seen the deviations taken from arithmetic mean. Here, in case of assumed mean, we are going to see how the correlation is computed through the deviations taken from assumed mean. Taken from an assumed mean. Assumed mean is known as A. Right, we are going to find out the deviations from assumed mean. For example, for x, we are going to take like x minus a. Likewise, for y, we are going to take x minus y minus a. Y minus a. Right. This will be the value which we are going to select from y, and this will be the value which we are going to select from x. This is how we are going to compute. And the formula which we have seen in direct method, on that basis itself we can learn this method. I'm just writing down the method which we have seen in case of direct method, the first method of coefficient correlation. The formula, what was the formula? The formula was n summation of xy minus summation of x into summation of y whole divided by root over n summation of x square minus summation of x whole square multiplied by, for y we are going to write, why I'm writing is on the basis of this I'll tell you how to frame the formula for assume mean method, right? Wherever you are getting, I'm using different color so that you can easily identify. okay, wherever n will be there, no doubt n will be there. Wherever you have written x, you are going to write down small dx. It means deviations from x variable. Wherever you have written y, you are going to write dy. The formula exactly will be the same. The only thing is you are going to use dx and dy. In place of x, wherever x is there, you are going to write down dx. Wherever y is there, you are going to write dy. So let us go for framing the formula under assumed mean method, right? R is equal to, I'll write completely, assumed mean method. Direct method I have told in order to frame, because there is no need that you go for by hearting the formula, right? Here it is x, we are going to write summation of dx dy. Here what you have to do, you have to find out the dx, you have to find out the dy, and both you have to multiply and you have to find out the total, right? Summation of x is there, you are going to write summation of dx into summation of dy. If you want, you can put in bracket. Since it is small x, no, I'm just right. And here n summation of, here x is there, we are going to write dx square. Here x is there, we are going to write dx, okay, whole square, root over n summation of, here y is there, you can write dy square minus here y is there, summation of dy whole square. This is the formula of assumed mean method. This is the formula of assumed mean. I'll just explain you what dx refers to what. Okay, dx, this is nothing but deviation. Since we are having two variables x and y, for x we are putting dx and for y we are putting dy. This is the only thing. Remaining all things are as usual. Okay, so dx, what do you mean by dx? Dx means deviations taken from, deviations of x variable, deviations of x variable from an assumed mean. Simply you can write x minus a. In case of y, it is y minus a. You need to find out the square of this, you need to find out the square of this. These are the values which you have to find out, right? Let us see. For example, x is given in the question, right? Y is given in the question. All x related values I will be doing after x, then accordingly we can do. Okay, so first of all, for x, what you have to do, x and y will be given in the question. X and y will be provided you in the question. First of all, you have to find out dx, right? You have to find out dx. Before finding out the dx from x variable, you have to take one assume in. Assume in any value you can take, but probably if you take the value which is not too high or too small, that would be better for easy calculations, right? So this you can do it, x you can find out, and this you have to compute dx is equal to, formula is x minus a. From this values itself you can select one. You can select one which is not in the series. You can select the smallest value. You can select the biggest value in x. Whatever you can do, whatever you are doing, you will be getting the same answer. But for simplification of calculation, it is better that you select the value which is not too big or too small. Okay. Then you have found the dx. Then you have to double it. dx need to be doubled. dx square. Then you have to find out. Then you are writing this is question figure, right? Then you have to find out dy. The formula of dy is y minus a. This a will be from here. Okay, this is the assumed mean of y series. Then you have to find out dy square. Then ultimately you are going to find out dx dy. Means this and this you are going to multiply. You are going to find out the total of everything. Whatever values you have computed, the total of everything you have to find in order to find out the answer. Right. Let us go for one sum. I'm just giving you one sum. Okay. So from this what you have to do is you have to compute the value of correlation. You have to compute the value of Karl Pearson's coefficient of correlation from this data. I'm just writing the data, and here what data I'll be giving you. Okay. And also they have mentioned that you have to take 69 as assumed mean for x variable and 112 as assumed mean for y variable. This is what it is being asked. Okay, 69 as x variable, assume mean for x variable, and 112 assume mean for y variable. Let me tell you the question. What is the question? Read out the question. Okay. Yes, this is the question. Find Karl Pearson's coefficient of correlation between the values of x and y. Right, x is given, y is given, and here in most of the cases they may not give you like this assume mean. You have to take from x series. This 69 is known as the is to be taken as assume mean, and 112 is to be taken as assume. In case if it in question it is being provided, to that value you have to take. Right. So for x we are going to take 69, and for y we are going to take 112. So one work is less here because we no need to select the assume mean, right? So I have just given taken the sum x and y. I have just written here. Let us, before that I'll write the formula also. R is equal to, formula is very simple, summation of dx dy, right, minus summation of dx into summation of dy. This point denotes into. Okay, whole divided by first for x we will take n summation of dx square minus summation of dx whole square. This formula easily you can memorize in case if you take the first formula which we have seen, right, multiplied by into, here we are going to take dy, summation of dy square minus summation of dy whole square. This is what we are going to take. Okay, this is the formula. So now what we have to do is, first what we have to do is we have to find out dx, which is equal to x minus a. Here the value a is what, 69 for x, right? And for dy we are going to take y minus a, and y is what, 112. Okay, we have that values here. No, they look 69 and 112. So first we will find out small y, right? Small y. I'll just make the column little bigger. Just make the column little bigger. Okay, I'll just put it here. Okay, yes, now you can see y, not y, it is x, sorry, it is not y, it is x, because here we are computing what, x. I'll just write down x here. I'll just write down x here. X means what x you are going to write, dx, right? This is for dx, this is your dx square, this is your small y, and this is your dy square, and this is your dx dy. So these columns are not required. I've drawn more columns. I'll just remove these columns so that no confusion should be there, right? We'll delete these columns. Okay, this we are going to centrate. Okay, so this is the value which you are going to see. Total we are going to write. So I have just made that cell little bigger. Okay, So now what we have to find out is we are going to find out dx. Here it will be dy. So the formula which we have seen in direct method, same formula. In place of x we are using dx, in place of y we are using dy. That's all. Okay, so what will the formula here? It will be x minus 69, right? Here x minus 112, here capital Y minus 112, here x minus 69. This is the formula. I'll use different color. Dx solution, I'll be using different color. Okay, 69. 78 minus 69 is plus 9. You can write down like this. I'll remove the cursor. Okay. 89 minus 69 is 20 plus 20 plus 20. Yeah. One minute. Yes, here 89, it is plus 20. Then 96 is plus 27. Right, 69, 69. If you subtract, it will be 0. 59 and that is minus 10. 79 is plus 10. 68 is minus 1. And 61 is minus 8. Right? Here the values you can see 1, 2, 3, 4, 5, 6, 7, 8. Here n is equal to how much? 8. Right? Here you will be taking 8. So you can find out the total of this. Summation of dx is equal to 47. Okay, now double it. X square, dx square. 9 into 9, 81. 20, 20, 400. 27 is 729. 0, 0 is 0. 10, 10 is 100. 10, 10 is 100. 1, 1, 1. 8, 8, 64. Summation of dx square, which is equal to 1475. Right. Now it is y. Find out dy. 125 minus 112. 125 minus 112 is plus 13. Right. Plus 13. And 137 is plus 25. 156 is also greater to 144. 12, 12 is 112. 112 is 0. This is minus 5. 136 is plus 24. 123 is plus 11. Plus values are bigger, you can see here. 108 minus 102, this is minus 4. Summation of dy is equal to 108. 108. Okay, now you have to double it. 13, 13 is 169. 25, 25 is 625. 44, 44 is 19360. 5, 5 is 25. 24, 24 is 576. 11, 11 is 121. And 4, 4 is 16. You can write down summation of dy square, which is equal to, if you're totaling, you will be getting 3468. 3468. Now you have to compute dx dy. Dx and dy. These two you have to multiply. And you have to write it down here. And you have to find out the total of dx dy, right? So dx dy, 9 into 13. 9 into 13 is 117, right? 20 into 25. 20 into 25 is 500. 27 into 44 is 1188. 0, 0 is 0. 25 into 10. Not 25. 5 into 10 is 50. 10 5s are 50. It is, both the values are in minus, so it will be plus. 10 24 is 240. 121 minus 1 plus 11 is minus 11. Minus 8 and minus 4 is 8 4s are 32. Again both the values are minus, so it will be in plus 32. Right. The value is 2116. Yes. Now we can put the values, right? We can put the values. I'm just going to delete this. These values I'm going to delete. Okay, we can compute here the values. R is equal to, what is x? X is 8, right? Into dx dy is how much? Dx dy into 2116. Dx is 47 and dy is 108. Numerator portion is over. Whole divided by root over n is 8, dx square is 1475 minus dx is 47 whole square. This is what you are going to do. Okay. 8 into dy square is 3486, sorry 3468 minus dy is 108 whole square. So the remaining question is easy. You can find out the solution, right? Is equal to 8 into 2116 is 16,928 minus 47 into 108 is 5,076. You can use your calculator and check the answers. 8 into 1475 is 11,800 minus 47 square. 47 into equal to, do it. You will be getting the double 2,209. Root over 8 into 3468 is 27,744 minus 108 whole square is 11,664. Right? 11,852 whole divided by, you just find out the root of this. You just subtract it, find out the root. If you want, you can do step by step, subtract, put one figure like 9591 16,080 is equal to 11,852 divided by 97.93 into 126.81. After taking the root of this, you are getting this. After taking the root of 16,080, you are getting this, right? 11,852 divided by, you just multiply it, the value will be 12,418.5033. You can take, after a point, you can take 2 digit, or accordingly you can take 0.954. So therefore R is equal to 0.954. What will be your interpretation here? Your interpretation, it is in positive, no? Your interpretation, it will be, there is high degree of positive correlation between X and positive correlation between, you can write completely, X and Y. So this is how assume mean method is. So I have explained you about the 3 methods under Karl Pearson so far. Under Karl Pearson's, we have seen 3 methods. Direct method. This method we will be using when the values of X and Y is less. Or we can say, in simple language, we can say it is 1 digit number or 2 digit number. At that time, you can use it. Okay. And second method is, we have seen, is arithmetic mean method. In case of arithmetic mean method, what you will see? you will check if the arithmetic mean of both the variables is in round figures. You can go for this method because it is easy in that case. Okay. Third method is assume mean. If it is not in round figure and the values are bigger, 3 digit data is there, because what happened if 3 digit, 4 digit, again if you are squaring it, it will be bigger value in case of direct method. So you can better use assumed mean method. But the thing is, you can use any of the method as per your convenience. But I have told you the situations when you can use the direct method, arithmetic mean method, and assumed mean method. Whatever method you are using, you will get the same answer. You will get the same answer, right? Whether you are using direct method, arithmetic mean method, assume mean method, any method, all the method will fetch you with the same result. That is why Karl Pearson's coefficient of correlation is widely used, and this is a rigid formula where everyone computing with the same set of figures will be getting the same answer. If any doubt, you can revert back. Thank you.